Welcome to Season 15, Episode 5 of Seen from Above. In this episode, Julia Wagemann speaks with Matthias Mohr, founder of Mohr Geo. Matthias is one of the leading figures behind STAC, the Spatial-Temporal Asset Catalog, a common language for discovering and accessing geospatial data that has become a widely adopted industry standard. In this episode, we explore how STAC came about, how it works in practice, and why having vast amounts of data means little if people can't easily find and use it. We also hear Matthias' perspective on where the industry is heading over the next decade and why making data truly accessible and usable remains the defining challenge of our time.
Matthias, hi, welcome to the podcast.
Hello, thanks for having me.
So, Matthias, you're an independent software developer and also one of the leading figures in the development of STAC and also the STAC API specification. For someone who does not know a lot about STAC and what it can do for geospatial or what it does in the geospatial industry, what is STAC and what problem does it solve?
Yeah, so first of all, STAC is a short for a spatial temporal asset catalog. So if you hear that, that's the same. So usually I start my presentations when I talk about STAC with a slide that shows like dozens of data portals. And I think you all know this landscape of data portals where every data portal looks different. And each data portal has a different API in the background. You have completely different behavior. You may find, for example, search for cloud cover in that API. And for some, it goes from 0 to 1. For some, it goes from 0 to 100, right? So percent or the other way of expressing it. This was not standardized at all. You all saw a proliferation of portals of how to find data and how to download data. You needed accounts for each different data portal, and that just didn't really work for the user community, I think. You may even not know a portal, and then you can't really find the data anyway, because you don't know that it's there. And that's the main purpose of STAC, to make data discoverable, to harmonize the metadata around it and the data access mechanism. It's pretty much, you can see it as a common language for EO data, let's say, or geospatial data, how you describe your data holdings that you offer to the world. Yeah, that's pretty much the main idea behind it, where we came from. Nowadays, it has shifted a bit towards more use cases and so on. But that was the main idea, was for search and discovery purposes. That is the main use case, which you still see in various places, and why things are the way it is in STAC.
So the principal idea was to have like one language that can be used to access and discover data on different data portals, and to only have like one API language or code you can then also reuse.
Exactly. And in addition to that, of course, due to the way it works, because it's machine readable, you can also use it not only from a web data portal, but also through programming libraries, for example. So in Python, in R, you can browse it through a common interface. So because everyone uses the same language, you can, for example, set up let's say a data portal that connects to all of these different offerings at the same time. So in that way, you can have a single entry point to all the data sets or the APIs that are.
So these attempts to have like a standardized data access, I think it's like it's nothing new. And I think one of the biggest challenges is like the fragmented landscape, and we have like so many different data access patterns and ways to access the data. So what was the differentiator for STAC that the community now really agreed on it and as the standard now to access large volumes of geospatial data?
Yeah, that's a good question. Before STAC appeared, I think the main way of exposing data was through CSW, so the OGC standard. That was the API mechanism. And then you had pretty much the ISO standards, ISO 19115, for example, the XML-based metadata standards. But they were very complex, and due to the way XML works, were restricted to whatever was defined in the standard, pretty much. Time shifted, like things developed over time, and both of these standards didn't seem to really be, that well integrated into how the IT world developed, it seems. For example, the shift from JSON to XML, you had much more use case, much more satellites coming up with different sensors, and different types of data were available. And the extensibility of STAC also helped quite a bit, I think, with that regard. So the core STAC specification is rather slim, and that is by design, but it offers an extension mechanism so that you can define your own extensions for your data. And I think that's a big selling point here. And then I think it was the right thing at the right time. The approach was a bit different than it was, like standards were developed before, from a bottom up approach, pretty much, where Chris Holmes pretty much gathered various people, industry, governments, and other stakeholders together in a room, pretty much, and just said, let's start it and let's try what we come up with. And that's pretty much how it started. So it was really use case driven, implementation driven, from the beginning. And I think that really involved people and kept them there. And then it just like was the right persons in the right room that were mandating for it as well. And then all the others pretty much adopted it as well, because the I guess leaders in the industry were recommending it.
And probably also it was the time where the problem was just like, it was like big, or the pain was big enough at that time, and also like growing, right?
Yeah, and there was also the shift from like your local computing, right? The old way of downloading data to your local computer and then opening it in ArcGIS or QGIS. At the same time, we're also shifting because the data grew much larger. We had the Sentinel satellites that were pumping out data as crazy. And so you had to start managing it differently and getting away from this traditional approach of downloading and processing locally, coming to cloud native infrastructures pretty much, where a different approach was also needed for the data sets. Where we are coming to the differentiation between STAC and STAC APIs in the end. That's an important part there as well.
This is actually a good point. So, like, for someone, like when you start exploring STAC catalogs, then you often see a differentiation between STAC catalogs and STAC APIs. But what is actually the difference, or is there even a difference?
Yeah, there is a difference, and I think we didn't do a very good job explaining it. Also mixing up the terminologies a bit. So there are actually two repositories that have two different specifications in them on GitHub, where we develop the specifications. One is the STAC minus spec repository, and the other one is the STAC minus API minus spec repository. The first one, the STAC spec repository, describes the metadata language and how to combine these metadata properties into files, into JSON files. The JSON files can be placed alongside data on static cloud storage. So if you have, for example, all your Sentinel images on a cloud storage, on AWS or Azure or Google Cloud, you can simply add the JSON files that describe your STAC entities alongside these files and point from the STAC files to the actual imagery. That's what we call the static catalog in the end, because it sits statically on a file system in the end, which you can then use as your entry point to the data. You browse or explore the data through the STAC catalog, and then can get the data that sits usually very unorganized on our cloud buckets. So that helps you explore it. The issue there is that a static catalog is pretty much just sitting there, and you need to browse through it manually to find the corresponding data. Otherwise, you need to ingest the whole catalog, which of course can be thousands of files. That is painful, and that's where the STAC API comes in, which is the API part. So I would call it the dynamic part, because that's where you start having usually a database in the background where you ingest all the stack entities into. And then you can use the API to query the database and get dynamic results. So that's for search capabilities, for filtering, for sorting, all these kinds of things that are more dynamic, for aggregations, for example, as well. That's where the API comes into place. And the API itself is a separate specification because it describes pretty much the communication between your client and the server that offers it. The API itself is based on OGC API features, so it's aligned with the OGC API ecosystem as well. The aim is to always align as much as possible with the OGC APIs as well, so that the STAC API fits into that ecosystem as well.
Okay, as a user, would do I? For me, it sounds like with the STAC API, it's much more flexible because I can easily, or I can query the data and I can get only the data back I'm interested in. What I understand, it's not as easy with a STAC catalog. Would you say as a user, it actually it makes most sense to only interact with a STAC API, or what are actually use cases for using or interacting with a STAC catalog?
Yeah, as a user, you would always want an API in the end because you can search through the API and get exactly what you want. The issue is it's easier to publish a static STAC catalog because you can just put it on your cloud storage and don't need to maintain the API in the background. So, for example, from a company perspective, I think it is well worth opening an API. They can maintain that and offer it to users, which gives them a lot of benefit because users can exactly search for what they need. But if you're thinking about, for example, research from a university perspective, you often have these like 3-year grants or so where someone works on something and then puts it somewhere as open data onto a cloud bucket, ideally, or somewhere else where like Zenodo or these other hosting platforms. There, an API is pretty much a burden because at the end, usually the funding runs out and the API is gone, and then you have nothing anymore that you can point to. So in that sense, offering a static STAC catalog is much more like is a long-term solution, pretty much. As long as you host the data, it's still there, and you can access it through STAC, right? It's a bit of a maintenance issue in that regard. So both are options, and I would say ideally we would have APIs for everything, but well, it's just not feasible for everyone to maintain an API. Yeah. So that's the perspective of a data provider. From a user perspective, an API would always be good. There might be a chance. I mean, we have, for example, the Source Cooperative hosting utility from Radiant Earth, right, where you can host data already, where a static catalog, for example, is a possibility to add. But maybe there is a similar service at some point coming up who just ingests all the data from static catalogs and offers it through an API. That would be something that I think we can do from the community. I started somewhat with at least with the STAC Index platform, where you can at least find all the different data sets. The idea was also to ingest the static catalogs and offer it through an API. I never got to that in the end, but that's still the idea. I think if someone would step up and has the time and funding to work on that, that would be very valuable to offer this in a dynamic way to users so that they can search through it without needing to like browse manually through all these static catalogs to find.
Yeah, I absolutely agree. Like also that is also helpful to enable a search to know, okay, where is like, if I'm interested in Sentinel-2 or Sentinel-1 data, and what catalogs or APIs the data is actually available.
Yeah, exactly. That's the other issue I think that we have, that of course often the data is published in different places and then it looks very similar, but sometimes there are small details in there that should ideally be solved by the metadata that providers provide through STAC. But that's often not the case. So it's sometimes hard to distinguish which of the different like data sets that are there for very similar source data pretty much is that data that you actually need and want. And that's also something like initially STAC API was focused on item search, so that you find the individual acquisitions, let's say, satellite terminology at least. But you also, first of all, sometimes need to find the right collection. Like we have this differentiation in STAC between catalogs, collections, and items and assets, pretty much, which are entities in STAC that we should probably describe as well, otherwise it gets confusing. So a catalog is for grouping individual things together, pretty much, like a folder on a file system. An item describes individual chunks of data. Usually, for example, in the case of a satellite, it's a single image with different bands, for example. That's an item, so one Sentinel-2 capture, for example. And the collection is pretty much the overarching thing that describes a set of catalogs and items with like the high-level metadata, which you don't repeat on each individual item, but it gives you a description of what's inside all these items, what's the license of it, who provides it, the usual things like title, description, and so on. And then the assets live inside either collections or items and are the actual pointers to the data files. So usually one asset corresponds to one individual file on the file system.
Yeah, in the description, it's also saying that like it could be either catalog or a collection. Like the collection, what it gives you, it gives like additional metadata describing the catalog and the assets. But in practical terms, do you see actually like a standalone catalogs, or actually in the end everything is packaged as a collection?
Yeah, so catalogs only really exist in the static world. In the API, we usually only have collections and items because you can directly see the group of things that is described through a collection, and then you can filter through the collection and find individual items, exactly the ones that you need. That's a bit different in the static catalog world, because there, if you just have a single collection and then thousands of files in a file system, and the collection needs to point to each individual item, the file gets overly large because it has a link to each of the individual items. So we use catalogs as a way to substructure the collection into what you usually do also in the file system with folders. For example, for Sentinel-2, I see often that people start with like a collection that is Sentinel-2, and then substructure, for example, into years, and then into months, and then into days, and then you have the individual files per day in a folder or so. And all these different sub-levels, the years, months, days, would each be catalogs that just give you the additional information. This is for year 2020. And here are the individual months that you can look through, right? So it's pretty much a subgrouping so that you don't have a list of thousands of files or links in the collection directly. It makes the from a data perspective, user perspective, the data more browsable as well and more findable. That reduces that there's no search, right? That's the part that is improved a bit by that.
Yeah, and absolutely, it makes sense, and also like more organized on how to find information.
Yeah,
All right.
exactly.
One question which I'm quite interested in, like what you respond to, is STAC only for raster data, or can STAC also be used for vector data?
Yeah, that's an interesting question and something I got asked a lot recently. The funny part is that in the beginning, the STAC website explicitly stated somewhere in the FAQs, STAC is for raster data, not for vector data. I think that is wrong, and we've updated that since then. I think you can always say for raster, yes. For vector, it depends. And the point is the overhead. So if you want to expose individual features or geometries, right? For example, a single point or a single polygon somewhere, then the overhead of STAC is rather large. You can compare that to rasters to some extent, because you wouldn't expose an individual pixel from a raster file, which is a bit comparable to an individual point in the feature world or in the vector world. You wouldn't expose a single pixel, because then you would describe each individual pixel with a JSON file. And that doesn't make sense. Overhead is just too large, right? You have GeoJSON file for each individual measurement pretty much. And that's the same in the vector world. So the raster data that you usually expose is already a chunk of data, right? It's a compilation of multiple measurements pretty much in a raster file, which originates from the original satellites usually. And how they capture images. And I would say the same is true for vector data, where you can, for example, store a chunk of vector information in a geoparquet file, in a geopackage, or in a shape file, where usually you have hundreds or thousands of geometries combined. This is the place where you can use STAC to point to these individual chunks of data that are stored in a file. You usually wouldn't use it for pointing to a single GeoJSON feature, because a STAC item itself is a GeoJSON feature. So there is also the difference again, like the mixture between metadata and data, right? If the individual geometries are your data, then you also have the same repeated again in the STAC item where it's the metadata. So this is the primary difference. I would say as long as your chunk of data is large enough that the overhead of the STAC item doesn't really matter, then yes. If it's for individual points, geometries or so, there are other ways of doing that, and that's where the OGC API integration comes into play. Then you would probably expose just an OGC API features, which is exactly meant for that purpose, for making individual features available.
Are there already examples of STAC catalogs containing vector data?
Yes, there are. For example, so the way it is done for many is right now that, for example, either they expose vector data itself as STAC items. For example, we have the FIBOA project, which exposes field boundaries, which are itself geoparquet files. And then we have, for example, per administrative division, usually country, sometimes a smaller level, but we have then the field boundaries exposed in geoparquet through STAC as well. So you can find those. You usually would add the table extension to that metadata, which describes individual columns in the files more specifically and gives information about which column is the geometry column and so on. And then the other thing that some implementations do, where it's more like exposing vector data through the collection, is that because like it's pretty much to avoid the issue that we had with static catalogs before, that you can't search it. Some create vector, like geoparquet files that contain the STAC metadata, right? Because each STAC entity is the vector data as well, again, or vector metadata, let's say. The geometry, which is the footprint of the data, and then individual properties. They pretty much create a geoparquet file of the STAC metadata. And they expose that in the collection as an asset, so that people can go through that geoparquet file and query through that instead of going through the individual items that are stored alongside the data. And as a geoparquet is cloud native, you can use DuckDB or any of the new tooling to make use of that and really easily go through the files and find the things that you need without actually hosting an API. So that's some way to mitigate the lack of an API and the database in the background. But pretty much now then your geoparquet file is a database, and through the tooling that we have nowadays, you can use that as an on-the-fly database, let's say.
This is like this, it's quite recent, this development, right? It's like the STAC geoparquet library.
Yeah, exactly.
Or
STAC geoparquet is the name. And the evolvement, especially of DuckDB recently, made that much more viable and much more easy for users to work through and use. Yeah, that's very recent, last 1-2 years.
Do you think this will become one fundamental thing of the STAC world, or it has potential?
Yeah, it has a lot of potential, especially because it's so low maintenance. We still need to see how good that actually works. It's still rather technical to use the geoparquet files in DuckDB. You need to know SQL. There are UI tools developed that could improve that inside the DuckDB ecosystem. But yeah, I think it still needs a bit more tooling in the end to get to a point where this is really user-friendly as an API with the corresponding UI would be. But there is a future for that, definitely. The other part is that due to the way geoparquet works, you need to generate the files in a way that they're ideally also ingestible by a browser directly, so that you can write tooling on top of that. geoparquet, again, is stored in chunks. They can be rather big or rather small. In a browser, it should be rather small. Otherwise, you run into the limits of your browser pretty much. So if you keep that in mind, and I think especially the geoparquet files that we create with STAC entities in them are rather than processing or data analytics, that should be taken into account, that you actually expose the files in a way that browsers can read them. So in the end, you may not even need DuckDB to look at them or visualize them in a browser. That would also be an interesting thing, I think. If you can just like go to a website and there is a static catalog in the background, and you can query it through the geoparquet files. That's, I think, the next step that we need to enable, and then we're much closer to it. So, yeah, I wouldn't say it's replacing STAC or anything. It's just an addition that really helps to make static STAC catalogs much more viable. Even in a catalog, in an API context, this can be helpful. So we've seen that on the Microsoft Planetary Computer, they have an API, but it seems it's a bit difficult. Like the larger the database gets, the harder it is to actually scale the whole thing. So they add these geoparquet files as well to make or offer that to users so that they can use them without the API in the background to search through the individual items.
Excellent. So absolutely, like in any case, very exciting developments. And there's still a lot of potential. And often like the developments are motivated by challenges you then come across, right? Like if you grow with a STAC catalog or like a STAC API, and then you say it's getting slow, and then other inventions and ideas coming up. Regarding like besides STAC, you also like one of the leading people in developing the OpenEO API, and maybe you can also briefly just say what is actually the OpenEO API and how does it differ from STAC?
Yeah, so the background is I started pretty much at the university in the project called OpenEO, which is a processing API for geospatial data. It works on the concept of data cubes and gives you processes at your hand that you can execute on geospatial data and can add or combine to a workflow. And due to the fact that this is all abstracted into OpenEO processes, there is a common language that you can run on individual services. So you can then translate that into the native processing engine that works somewhere, which can, for example, be Google Earth Engine or any other cloud service. And by that, in the end, the idea is that you write your workflow once, and then with just minor adaptations, you can run it on various different services. That, of course, helps because you can actually check whether the results that you get from one backend are correct. You can verify that the same results, for example, in Google Earth Engine, which is a black box internally, you never know whether the results that you get are correct. Whether the same results would be computed on another instance that is, for example, the Copernicus data space ecosystem, which is one of the services that also offers an OpenEO API. That also reduces the vendor lock-in, of course, a bit, because you can just move your workflows from one backend to the other. That's the basic idea behind OpenEO. And the connection to STAC was that right at the beginning, when I was trying to write the API specification for OpenEO, there was not just a need, of course, for processing, but first of all, you need to find what data sets are actually available. So we needed a way to describe the data. And I looked around what's out there. And when we started OpenEO, the OGC APIs were pretty much non-existent at that point. We had an early version of OGC API features, but otherwise just the OW whatever S, like web services. So that didn't fit with the OpenEO API. So we looked around and found the early initiative of STAC pretty much. That was really early in version 0.4 or something. So really early. And then actually OpenEO proposed the concept of a collection to STAC, and we created that within the STAC ecosystem. And then it just started to evolve from there. Not sure how all that really happened, but like STAC exploded. OpenEO is slowly growing, but yeah, it's interesting how this like side hustle pretty much for OpenEO resulted in this big growth of STAC as well. It's very interesting how that all evolved. Nowadays, I'm doing much more STAC work than OpenEO work actually. But yeah, that's a connection between the two, which pretty much came from a bet from Chris Holmes again, who just like said, "Yeah, we're starting from scratch. I just invite this random person from Germany who is completely new. I never heard about him, and invite him over to the US to the third STAC sprint." Just crazy how this all evolves over time and how this all came into place.
Maybe you can explain a bit more, like how this worked in the end, like how you got involved with STAC, and so you already started a bit, but maybe you can now elaborate a bit more on. It's a fascinating story. Like when you started, STAC was like just really at the beginning, and it was like very like needs driven, right? Because you had a need in another project, but maybe you can guide us a bit more, like also through the last years on how STAC picked up very long, and like what was your role there?
Yeah, so yeah, it started with the OpenEO need for data discovery. So I found that and then just opened random issues with questions on the GitHub repository pretty much. And then at some point, I can't even remember how that, we just had a call with Chris Holmes and asked about like what the plans are, what our requirements are, and whether they can be accommodated within STAC. And it wasn't really clear because at that time they were primarily thinking about items, so the individual files. But in OpenEO, we don't really have, we have files in the background, but we don't expose them. Our main intention is not the data access itself. So in the downloading the files, but just like making the data cube of data available to users. So we really only use in the core the collection specification, and that was not there at that point. Another person that got invited to that third STAC sprint that Chris Holmes invited me to was Simon Ilyushenko from Google Earth Engine. And they have a similar need because they don't really offer the items for download, but instead they offer in the individual collections so that you can process on top of those without really worrying about the files that are underneath of that. So we both worked out the collection specification at the third sprint and added that to the specification. Yeah, and from there it evolved over various sprints. With always this like a very development or user-centric approach where we often met in the US for a sprint. That's at least the name, which were usually discussion rounds with a bit of hackathon, let's say, attached to it, where you just implement things. Yeah, and then it just evolved from there. We made various releases over time to accommodate for the feedback that we had, and then eventually we felt confident about the specification and released the 1.0 version. At that time, we also started the STAC PSC to govern the whole effort, which was back in the day, we started with the main contributors pretty much. So that was Chris Holmes, Matt Hansen, James Banting, Rob Emanuel, and me. And then we just let it run for a while. The ecosystem evolved, the implementations, the extensions grew much more than I think we initially thought they would be. Nowadays, there are 80 plus extensions, so it's really hard to actually figure out what the right extensions for a use case are. And recently we had then released a 1.1 version of STAC, which adds a couple of things that evolved over time in different directions, primarily the for example, bands in the EO extension, with bands in the raster extension. We not merged them into a single band construct. So we are pretty much just cleaning up after ourselves the things that we got wrong in the first iteration, but kept it relatively backward compatible so that it's not really a big effort to migrate to the new version. And afterwards, and that's just happened very recently, we had some person stepping down from the PSC due to the fact that they just had different priorities in the work life or switched roles, and now added 5 more people to the PSC. So Matt Hansen and me stayed on the PSC, and we added Julia, Alex, Michelle, Emmanuel. Anyway, yeah, there are 5 new people, and we're trying to just steer the whole ship again into a direction where it needs to go. We're still trying to figure out which direction that exactly is. So we'll have, for example, at the upcoming CNG conference, we'll have probably a birds of feather about the future of STAC to just get a bit of input from the users and the stakeholders in STAC about what the future for their perspective should look like or what they need, and then figure out how we can manage all this a bit better. Also keeping just things together, right? The proliferation of extensions, for example, is just getting a bit out of hand. Some say it's a bit like the Wild West, because everyone is just creating extensions out of nowhere without like a lot of oversight from the PSC. And then you end up with 3 different extensions for CMake6, for example. And all these things need a bit of guidance, I guess, so that it's not just is completely crazy and unmanageable for people. Just remember the missing person was Pete Podomsky. Anyway, now they are complete. Yeah, and I'm looking forward to leading that approach or that PSC forward into the future, and let's see how that goes. That's where we appear in the current terms, pretty much.
It's absolutely, or I'm quite excited to see like where all the things regarding STAC are going in the future. And probably one part is also like to, on one hand, like you all push boundaries in developing the standard and making it as useful and applicable and applied as possible. And probably on one hand is like also now trying to bring everyone who works with Earth observation data and will be in the need to use STAC to also bring here like the masses in making it possible to use STAC better.
Mm-hmm.
Probably this brings me to one of the questions, and maybe you can just give your perspective on that, because you work a lot with organizations adopting STAC and probably also want to set up STAC APIs and catalogs, but also practitioners, I guess, using STAC. Can you summarize, like, can you say like, okay, there are like some, are there a few challenges organizations and practitioners encounter when they start using STAC or trying to adopt STAC?
Yeah, so the most commonly asked question is probably, how do I structure my data? So because STAC is so flexible, it also gives you a lot of options. And that is at the beginning probably overwhelming. And it's always hard to like, if you generate thousands of things with a lot of cost in the background, it's probably hard to just say, yes, I'll do it this way, and then realize later on, oh, that might not have been the best idea. So yeah, that's a question I hear often, like, especially if you expose a static catalog, like how do I structure the data? Which metadata do I actually need to add so that the tooling can read it? And there are certain best practices around, but I think we can improve on that and make a bit more, like give a bit more guidance towards data providers how to make useful STAC catalogs. Yeah, and then of course, technical challenges always come up, like how do I set up my API and how do I scale it up? That's of course one question that is more tied to the API specification and exposing a database and an API. On top of that, then of course, I've briefly mentioned that the number of extensions is an issue because it's hard to navigate which extensions to use and which are actually useful for the use case or for the data that they offer. Yeah, that's also something where I think additional documentation could help. And then, yeah, it is also a bit, we still need to teach people a bit, let's say, that the initial intention of Stack was search and discovery. And people often use it for everything. They just dump all their data in there, sometimes even without like using the actual metadata fields in Stack. So the interoperability is not really there anymore. It just pretty much use it as a GeoJSON, JSON-ish container for whatever they have. And that should not be the case. At least whatever is defined in Stack should be described in the way that Stack defines it. And then, of course, you can add things on top. That's always the case. But Stack is also never meant to be a full replacement for other metadata languages, like the ISO standards or so. You can still link to them. You don't need to expose all the data that you have in your existing metadata offerings in Stack. It's pretty much like an overview of what you have. So yeah, that's something that you still sometimes need to stop people. And then the other part is, of course, the name is spatial temporal asset catalog. And some people have other data that, on first sight at least, have no spatial or temporal component. Then you need to offer alternatives, which nowadays it's easier because you have the OGC API records, which is closely aligned with Stack, so you can mix them to some extent at least. There are certain challenges around that, but we're working on improving that as well, so that you can expose also like non-spatial temporal data in addition, because otherwise it is indeed a little limiting. That Stack stops at some point and is bound to the spatial temporal aspect. But yeah, that's, I think, the main issues, apart from all the technical details in the background, of course, that occur.
Yeah, like coming back to like also just helping people to understand the nomenclatures, like the difference between catalog and collection and asset and item, and like what is actually what when we bring it down to Earth observation. So when we run courses, we actually use an analogy and we ask people to set up a Stack catalog with beverages. So like they basically start thinking like, okay, how would we actually logically group like cold and hot beverages? And then like if we go into a detail, what is then actually like, cold beverages, we can also still say soda and water, or like hot beverages like coffee. And this helps a lot, like specifically for those who are new to the Stack world, to first understand also just, okay, what is actually an asset and an item and the collection and the catalog, which we saw it is a bit difficult when we start with like Earth observation data and bringing it down. I just wanted to mention this, sometimes to simplify things, that like to bring people on the same stage, and just having also understanding of the definitions and the namings will help. And then it's easier for them to also recognize, okay, this is now how the catalog is structured, for example. And this is what I find in an item or an asset.
Yeah, that sounds interesting. I would love to have a look at that, seeing some catalogs that around beverages.
Yeah, it would be. Yeah, let's do something. So I think definitely we can like show you, and then also get your expertise on it, and say like, okay, this makes sense, or like, no, not at all. Yeah, let's do something. If someone wants to get started with Stack, what would you recommend? How best to get started now? If you never worked with Stack before, but you heard a lot about it, and you say, okay, it's now time.
Yeah, I mean, first of all, I think there are various ways where we can improve this. I think there are still like a lot of tutorials or things missing in the ecosystem to get people on board. So I should love to hear the idea about the beverages. There is a group of people right now working on improving that. But if you start and look at what we have available right now, I would start with the tutorials on the Stack specification website directly, or stackspec.org. And then I think it's mostly getting used to it. So as you said, with the beverages, that's a good start. What I did in past workshops is often to just give people one or two images from Open Aerial Map or something, and then ask them to just like create the JSON files from scratch, creating a collection and one or two items, and just to get used and navigate the ecosystem a bit without tooling, without the hassle to learn PyStack or any like language specific thing, just to get a feeling of the internal things, how things work. Apart from that, I think the other important bit is just communication and getting involved. I think the STAC community has always been very open to people, and it was very collaborative environment right from the beginning. We have STAC community calls that are just like an hour of call, pretty much. You can just come and listen in or introduce what you're working on. You can ask questions and so on. That's every Monday at 5 p.m. Central European Time. There is a Google group that I think is called STAC Community, where you can just subscribe to, and then you get an invite to the meeting. Otherwise, there's also the CNG, so Cloud Native Geospatial Forum Slack instance, which I think you need to be a member of nowadays. But there is a STAC channel in there, which you can join as well. If you're not a CNG member, then there is also still the old GitHub channel, which is open to everyone, where you can ask questions, or just the GitHub approach, opening issues or discussions or pull requests on GitHub is always a good way to get started, I think.
Excellent. Thanks for sharing. I'll also make sure to add all the links to the show notes. So hopefully you have like an influx of new active, proactive community members.
That would be great.
All right. So now we deep dived a lot into the world of STAC. The last 5 minutes, I'd like to use the opportunity to get your perspective more like on the broader perspective on where the industry is going. So one of the goals for this series at the moment is also to demystify the term cloud native geospatial. And you mentioned this already several times today. So in your own words, what is actually cloud native geospatial, and maybe also how do you see a role in shaping it?
Yeah, cloud native geospatial is a term that is just overloaded. I don't think there is one single definition, and if you ask 10 people, you get 10 different answers for it. So yeah, it has been all kinds of things over the past. I think in the broad sense, cloud native geospatial just makes your data suitable for the modern days of the internet, pretty much, and how we work with online storage and the cloud environments. I think that's just the basic goal of it. And then it depends a bit of what you're looking at. Yeah, so I mean, first of all, there is a shift to cloud native geospatial just because we have large amounts of data, of course, that we can't process locally anymore. And that's what we discussed before already at the beginning of the show. But the internet is now everywhere. And some even say the browser is pretty much your new operating system, right? Because you have everything that you in the past had as a program installed on your computer, you now can do in your browser as well. You have Google Doc in the browser instead of Word. You have online GISs such as Felt instead of ArcGIS and so on, right? So that's all shifting towards the browser, so towards the internet. So now making the data available in a way that it works in that environment is of course important. In the past, you could have downloaded a gigabyte of data and just open it in QGIS or ArcGIS, no problem. If you start to load a 1 gigabyte file into your browser, that doesn't really work. Memory limitations and so on. So that's one use case, right? Making the data available in a way that it can be used in that web online browser environment, let's say. But then the other part, of course, that is I think the second main cornerstone of cloud native geospatial is the data processing, data analytics. So making the data available on the cloud, and then you can run large-scale processing on top of it. In both cases, you only want to request the data that you really need. You don't want all the data. So making it available, easily consumable in chunks. And ideally also in overviews where you have pyramids of downscale data for specific extents that you're working on is an important part of that. And all this is pretty much meant with cloud native geospatial. So we make the file formats that you expose the data in, cloud friendly for this approach. So that in most cases you can request parts of the data via HTTP range requests. And the only issue I think primarily is that both of these primary use cases, the browser-based access and the access for data processing at a large scale, have certainly slightly different requirements, because for data analytics, you want rather large chunks so that the overhead of processing is not getting over your head. But on the other hand, you have the browsers, which needs rather small chunks for consumption in that environment. And yeah, there it is important there to find the right compromises, I think. And in many ways, you still need to do that. I think, for example, the cloud optimized geotiff found a sweet spot there, and that works relatively well for everyone. But I still see that there are improvements needed or guidance needed, for example, in GeoParquet or in ZAR, which are rather new. So of course, they still need to evolve, especially with regards to guiding users how to create these in a cloud native. That's, I think, the primary case. There might be others, of course, that have other use cases, but I think that's the primary two parts that play a role here.
Yeah, thanks for sharing your perspective. Now, if we look ahead the next 10 years, do you say the future of geospatial is in the cloud, and will we exclusively access geospatial data via STAC?
Yeah, I think so, because the amount of data that we are capturing, and we're sending even more satellites out, is exploding. So there is no way getting back to how it was before. We need to store it somewhere. We need to process it. Actually, I see that we have too much data available at hand, so that it gets a bit too much at some point as well. While at the same time, we don't really make already the most of the data that we already have. So there is a bit of a challenge here as well, that we might just have too much data at some point and can't we make proper use of it. So that's something I think that is a challenge in the next years as well, to make real use of the data and not just do something for the sake of it. We need to get real results out of the data for the benefit of the Earth. We're living in challenging times. I mean, we've seen it recently, right? The Ukraine war, the Palisades fires, etc. You have all the data, but it seems like at many times we have issues actually making use of that data in time. So that's, I think you spoke to Brianna Pagan before as well. She was rightly affected and wrote a long, I think, LinkedIn post about that, which I think shows really well the issues that we are facing right now. And we need to work on that to really bring the actual data that we have to the users, to the people. Otherwise we'll just have data sitting around in a cloud. And I mean, you can even say with all the electricity bills or need for power consumption there, it might even be like, if we don't make proper use of it, it might be even worse for the whole environment if we only store it somewhere and don't make proper use of it. Yeah, so that's, I think, the challenge in the next 10 years. Where we are exactly in 10 years, of course, is hard to imagine. If you think back 18 years ago, we invented or Apple invented the iPhone, so that's not so long. And now it changed the whole world pretty much. Yeah, that's, I think, the look ahead here. With regards to where STAC is, or where OpenEO or all the specifications are, that's hard to answer. I hope that just more data gets available in common formats, in specifications, that you get rid of silos that are difficult to access, of proprietary specification portals, so that it's just easy for users to get to the data and make use of it. And then I think we need to look a bit also into other domains. Right now, I mean, still STAC, if you speak about STAC, even in our niche domain here, people are not often aware of it or have a lack of understanding. But then if we go out of our niche here and, for example, talk to journalists or to other domains like insurance or just other parts of the industries that are not really EO specific or geospatial, we need to reach out and also make our data available there so that it's easy enough to make use of that. Yeah, that's, I think, the main challenges that we face. It's pretty much all, I think, if I summarize that, is all around making the data more accessible and usable. And that also brings us, I think, to the other part that I'm working on, which is analysis-ready data. All these kinds of things are the future, probably in the 10 next years. So a lot of challenges still to work on.
I think this is an excellent, nice final wish for the next 10 years. But at the same time, it's already good. Like, thank you for already your contributions up to now, because you work already to make data better accessible and discoverable. And let's see how things are in 10 years. So thank you so much, Matthias, for all your insights and perspectives and sharing this today with me. Yeah, hope to continue the conversation, and really looking forward to see what is happening with STAC and OpenEO in the next years.
Thank you as well. Thanks for having me, and also thanks for all your work around making data more accessible. You're actually teaching people, and that's, I think, exactly what I just said, right? We need to make it more accessible. So your work is very, I think, valuable in that domain. And thank you very much for that.
Thanks.